Welcome, everyone. Thank you for joining us this Thursday for our webinar Chemistry Hour series, Pre-Analytical Challenges, Part 1. Before we get started, I just wanted to go over some helpful areas on the console. Let me get over here for the webinar. So we will have a Q&A portion at the end of this webinar. So please feel free to ask questions at any point through the Q&A feature that can be found to the right of your console or down at the bottom. We will also have a survey that you can fill out with any feedback regarding today's webinar or topics you would like for us to discuss on future webinars. We appreciate any feedback you have for us. Please also take a look at our resources over on the left side of your console. These resources, in addition to the final presentation, will be emailed to you tomorrow, so be on the lookout for that. I'm going to now pass it over to Brandon, who will introduce our speaker for today's webinar.
Hi, my name is Brandon. I'm with Inside Sales. I'm here to help with some introductions and with a Q&A for this. I'm pleased to introduce Guy Boisvert. He's our clinical and forensic chemistry account manager for the US and Canada. Guy brings more than 28 years of experience at Waters. With his immense experience in chemistry product selection and post-sales support, Guy's mission is to help you save valuable time in method development by ensuring that you start with the right product from the outset. We are very fortunate to have him here with us today, and take it away, Guy.
Thank you very much, Brandon, for the introduction. I'm very glad to be here, everyone. So I just want to say that this presentation is done because I'm collecting some information since many years, and I look at the challenge that you have, and I think that sometimes it's good to share the information to everyone. And specifically for this seminar, we will talk about increasing sensitivity for acidic molecules and what we can do, because many times we see sensitivity as a detector only feature, but you probably know that sample preparation is also key, and column selection is also very key, specifically for those molecules, and I will show you why. In this presentation, you will probably recognize some of the slides that have been used in the past. That's okay, there's maybe a couple of slides, but most of the content is new. So stay with me. I just want to bring a very, very brief review on adsorption, and then we will look at some examples, real examples in the clinical field, and we will explain how it works literally. So this is when we develop method, we have sometimes wonderful days where we get all the critical attribute done very easily, and we get a robust method at the end, and bingo, it's done. We can go transfer that method to production without any problem. But sometimes we inject some molecules and we don't see anything. So we go back to inject again, we don't see anything. So we enter into a very, very panicking mode of troubleshooting. We can prepare the mobile phase again, re-prepare the standard, ask why the detector is not seeing in it, do the injector inject, do the detector detect. So we are going into a different situation to find out what's going on. And basically, just to give you an example, this is a real example. The molecule is insulin-like peptide, where you see it on the mass spec. Everything has been done to develop the MS method. And then when you inject, you don't see anything. So it's always what's going on, what happened. So, okay, that was something that we saw for this molecule. Then we can find some other peptides that have acidic residues, like aspartic acid, glutamic acid. So you can see them in red in the peptide sequence. So for peptides that have like 20% acidic residues, you see the bad tailing that we have, and that tailing will affect the sensitivity. So what happened into the other example of insulin-like peptide, the tailing was so bad and the absorption was so bad that we were unable to see it. And I remember, like maybe I would say probably 15 years ago, I was with a customer and we were looking at this kind of molecule, and he told me, Guy, do you sell conditioned columns that are already performing well as we open them from the box? And the answer was like, no, we won't. I cannot imagine doing all the columns and having them conditions or whatever with something to avoid that problem. So it was there 15 years ago, and we didn't have a real good answer at that time. We were doing our best to make it work, but we were not having a good solution at that time. So what happened? The columns are made with stainless steel. So you can imagine the tubing is in stainless steel, but also the frit at the end, where you have a lot of surface. They are metallic surface. They are there to maintain the powder inside the column. And it's also like a filter as well. It will diffuse also the sample into the column, altogether. And those metal surface are electron deficient. So they are like positively charged, or electron deficient is probably the most accurate. And when we have molecules that are electron rich, so you have phosphate, carboxylic, you have phosphonate, you have sulfate or sulfonate, they are rich in electron, and they will interact then with the surface. They will absorb. So we will observe a lower response, or we will also see extra tailing. So that's the effect that we saw. And there's one way to get over it. There are several ways. One was to add some additive in the mobile phase, but then it has an impact on the mass spec. It has an impact on the method robustness. But the goal was to, and we were talking about active sites, like the molecules we know was interacting with the column somehow. And we knew that those molecules were sticking on the metal surface. And it took a while before all the metal surface become dirty. And then the molecule will not adsorb on dirty surface. So it takes a while to cover that surface. And like the example I was giving you about 15 years ago, the customer was injecting 70 times high concentration of the peptide. And then they were able to see a nice peak. But before it was nothing. They were not seeing anything. And then later on, I saw the same problem. A customer that was looking at every lot of columns, and they were saying, like, in our QC, we do the evaluation of the column, and sometimes we don't see our peak. And I said, okay, that's the same problem. And we came into that kind of situation, and we resolved the problem. So there's a way also we can do, we can work with inert surface. So to give you, and I will explain a little bit later what are the MaxPeak Premier columns, but I just want to show you some examples, real examples again. Imagine that we are looking for those lipids. They have a phosphate group. They are negatively charged, so they are rich in electron. Both of them, lysophosphatic acid or phosphatic acid. And we see that on the conventional column, on the top trace, they adsorb, and we don't see that much the molecule on the fresh new columns. And when we go with the Premier, MaxPeak Premier column, those columns will not have the interactions with the acidic molecule, the acidic lipids in this case, and we see a much better peak. So you can imagine that if you are looking for sensitivity, you better go with the MaxPeak Premier columns. But again, I will show you more about not only those specific case, but I will come into which molecules will interact with the surface, when should you be concerned about it, and at the end, I will explain a little bit more about real examples also that we can find in addition to the lipids or some peptides. So if you see in the lab that you develop a method and you see that the column doesn't perform well up when you use it, but as you inject the sample many times, you can see an improvement in the peak shape and sensitivity. You most likely deal with adsorption. So that molecule will probably adsorb. If you see extra tailing on acidic molecule, most likely you have adsorption of that molecule on the metallic surface. And again, if you go at low detection, low concentration, that will be a severe effect. If you go at high concentration, you may not see that big effect as the, well, we will show the work that we have done to assess the adsorption at different concentration. But namely, there's a lot of molecules like nucleic acid, acidic peptide, proteins, glycans, small molecule. So if you do metabolite, if you are looking for different metabolites, they are mainly acidic, and they may be affected by the metal surface. So if you are looking for the lower detection limit, the lower limit of quantification, these will become critical. So I would like to come to present you this that is more like a general. It's not like molecules that you will do on a regular work in the clinical, but it's just a model. Just we want to see some acidic molecule, some diacid molecule, some phosphonic acid, sulfonic acid, diphosphonic and disulfonic acid. So those molecules are in the table down over there. They are in order of calculated charge at pH 3. So you see that the -2 is the most negatively charged molecule. And at the top for ibuprofen, you will see 0.014. So that's the least negatively charged molecule. So what we have done is to look at, we wanted to see if there was a correlation between the charge and the adsorption, and also if there was a difference from the concentration standpoint. So the more we inject, do we have more or less effect, and so on. And what we did to find this out, we look into the peak area ratio using two different columns. One that was a stainless steel surface, like a conventional column. You can think about the Cortex column, X-Bridge, XLX, AcuIT columns. And the other one was a Premier column. So in this case, we took the HSST3. So in both columns, they have the same sorbent, so the same particle size. The column are same geometry, 2.1 by 50 millimeter. The only difference is the surface of the columns. The Premier has a MaxPeak inert surface, and the AcuIT has the conventional metal surface. So we have here the ibuprofen that has one acidic function, and we see the azelaic acid with two acidic functions, succinic acid also, malonic acid with two acids. So we have the different number of carbon. Phthalic acid, also dicarboxylic on the benzyl group. And we have polysulfonic acid, we have polyphosphonic acid, we have the diphosphonic acid and the disulfonic acid. This is just like model to see, just to gauge the importance of adsorptions for acidic molecules. Okay, so what we did for each column, we took each analyte separately. So we started with ibuprofen, and we did inject different concentration on the column. So for the first injection, it was all the analyte was at 50 microgram per ml, and we were injecting 1 microliters on the column. We repeat that 6 times to get an average. And then this is the low mass load. And then we rinse 3 times with ammonia. So it was a 0.3% volume. So we inject 1 microliter. And this is just to clean the column, to bring the column back to the initial state. Okay. And after the 3 injections of ammonia, we inject 3 water blanks, and we go on with the upper or the mid concentration, for example, with 2.5 microliters of the same 50 microgram per ml. And for the higher concentration, we inject 5 microliters. So basically, we load 50 nanogram on column for the low mass, so 50 nanogram. The mid is 125 nanogram, and the high is 250 nanogram. It's not really important to remember those numbers, but we will see an example later, and we will be able to refer to the concentration that we are using here in this table. So we did that for all molecules on both columns, and we compare the area ratio. So on top, we have the stainless steel, and we have the relative to the max P. So the first observation we can see here is everything is under 1, which means that we see some adsorption on metallic surface, stainless steel surface. So all the area are lower on the stainless steel compared to the max peak. For everything, all concentration, all ionic charge. But the thing we can also see is that the effect is stronger when we go with the most acidic molecules. So the ibuprofen, the effect is not that huge, 0.86. And as we go down, or 0.93 or 0.91, this is not big deal so far, but you will see the effect later. And when we go down, we get to 0.7 and 0.27. That's huge. So like 27% of the surface, that's not a lot. And again, if you move to the mid mass and the high mass, you will see the same kind of effect. So as we go lower in charge, we see there's more effect, but we also see the trend from the low to the mid to the high mass. There's always more effect on the lowest mass, typically. And if we look into if we compare the phosphonic to the diphosphonic, we see that we go from 0.7 to 0.27. So the effect is drastic. So again, more charge, more effect. Same thing for the sulfonic acid and the disulfonic acid. And if you can also compare, if you want to compare the polysulfonic acid to the propyl phosphonic acid, you will see that both trends are similar, like 0.7, 0.72, 0.83, 0.82, 0.89, 0.85. So the trend is very, very similar. But if you compare the diphosphonic acid to the disulfonic acid, the last one in the table, you will see that the trends are not the same. So the disulfonic acid is really much more affected. Even at a higher concentration, it's still severely affected compared to the other one. So if you're looking to develop a method and you're looking for the lowest concentration. You want to push the detection limit for that method. That's important to realize that you still have some effect, whatever molecule, and you have more effect as it's more acidic. And we will see some real examples later. Just to give you an example of what we see, this is the diphosphonic acid at low mass. On the premier columns, we see a very high peak intensity, and on the stainless steel, it's much lower. So this is a gain of sensitivity. Here we compare and that will be good for people doing metabolomic. They are looking for the adenosine monophosphate, diphosphate, and triphosphate. Again, we see the trend. The more phosphate you have in the molecule, the more adsorptions you observe. So you can see that the ATP on the conventional hardware is highly affected, but on the Premier, we get good peak shape and much more sensitivity compared to the conventional hardware. Here we see some examples of antivirals. All the molecules, there's 11 antivirals. You will see in this case, the X-Bridge Premier will be the red trace, and the conventional column will be the black trace. And you will see that for all of them, you get more sensitivity on the Premier column. So that's just to give you some examples that we have seen. Methylmalonic acid, many people are looking for that kind of molecule. And again, maybe you will see some old paper that we're using the CSH phenylhexyl. Well, now that you know, it has 2 acids. If you want to increase the sensitivity of your method, you will just use the same column, but in the Premier hardware, and you will increase that sensitivity. So that becomes quite important. For the vitamin B and the vitamins, you will see that some vitamins have acidic functions, some have phosphate. So you will see, for example, the TPP, thiamine pyrophosphate. So you will see the 2 groups with a lot of phosphate and oxygen. You will see the NAD. So there's a lot of molecules with and the PLP, pyridoxal 5-phosphate. So again, those molecules we know will interact with, will absorb on metal surface on the regular column. So there will be a need to go on the Premier column hardware. And this is what you can see on this graph. The green peak is the max peak Premier, and the red will be the conventional column. And for all those cases over there, we see a better detection limit on the max peak. So what is the max peak column exactly? So it's a inert column hardware. So all the metallic surface, not only the tube, but all the frit and everything that comes in contact with the sample has been chemically modified. So covalently bond, the surface is hybrid, is no more metal oxide layer, and it is protecting the column forever. I mean, it will not leach, it will not bleed, it will not. You will not observe any deterioration of the column with time. It's just that it's a new surface that is in contact with the molecules. One of the benefits will be in mass spectrometry. On the conventional stainless steel column, you may see some iron adduct. And when you use the max peak Premier columns, because the surface doesn't have metal surface, it has been hybrid. We don't see those metal adduct. So that's much better spectra or better information. The other thing we need to also realize is we have many of the conventional column, you'll see on the right, the standard column, for example, the Acuity BEH C18. And on the left, you will see the same sorbent into a MaxPeak Premier column hardware. And as you can see, the peaks comes at the same retention time because it's the same packing material. It's the same BEH powder in both of them. So if you use the same mobile phase, same pH, same everything, you should get exactly the same retention, the same selectivity. Note that for non-ionic or positively charged molecule, there's no bad consequence on peak shape or whatever. It's really on the acidic molecules. And here look at the molecule 2 and 3. Molecule 2 is hydrocortisone phosphate, and the molecule 3 is dexamethasone phosphate, sorry. So those two phosphate molecule will have a better sensitivity on the MaxPeak Premier column. You see that the peaks are sharper and higher. And it will be the same on the BEH shield. It will be the same effect on the CSH C18. You can see the same effect in the phenylhexyl and the HSS C3. It's always same selectivity when we compare the conventional to the Premier, but better intensity of acidic molecules on the MaxPeak Premier. Sorry, I missed one. So this is a very, very important slide. I will tell you why it's very important. And it took a while for me to realize that importance of that slide. First of all, we see on the column, on the MaxPeak HPS, high performance surface, the inert column technology. In blue, we see the trace. So the column out of the box is giving us good performance. On the stainless steel, the first injections is very, very bad. And as we increase the number of injections, we start to make the column dirty. We start to coat those active sites with the molecule, and then we see the response that is changing. After 10 injections on this specific case, you may see, well, there's no big difference between the MaxPeak and the stainless steel. So in the R&D environment, you may be able to deal with it, saying, okay, I will inject 10 times my molecule or 20 times or 30 times, and I will be okay to work with my column for my study, for the development of my method. But if you think at the people in the production, they will need to follow that conditioning steps as well on each column. And this is taking a lot of time. And this is probably one reason why people really love the MaxPeak columns, because they work right as we use them. The other thing I would like to point on this one is that we are using 0.2 microgram of fructose or 200 nanogram. You remember when we talked about the small load, medium load, and high load? So this is basically like the high load. So if you remember again, on the high load, the effect was probably less relevant than at lower dosage. So you can imagine that instead to go with the 0.2, if we were at 0.05, like the 15 nanogram on column, the effect would be even greater than what we see right now. So again, if you are going to lower detection limit, it makes a huge difference. The other thing I would like to mention is if you have a column in your lab and you say, oh, yeah, I have those kind of molecules and I would like to compare with the MaxPeak, don't forget that if you use a column that has been used for hundreds of injections, it's probably already well conditioned. If you compare with the MaxPeak, you may not find any difference or a huge difference. But if you compare a brand new column to the MaxPeak column, then you will see the big difference between the columns. And this is what the columns will bring to you. A better robust or a more robust method in production. No need to condition the column at whatever concentration. This is key. Okay. This is the hardware that we have changed as well. As we introduced the Premier column, we said, well, can we revisit the design of the Vanguard? So you will see on the bottom of the picture, the left picture, we see the pre-column. We call them the Acuity, Vanguard pre-columns. They fit into the Acuity column. There's a small O-ring. We remove that. We sit the we position the pre-columns at the perfect positions on the column. We set them. It gives you a very, very long solution at the end where you have the columns plus the pre-columns. It's relatively long. On the top, you will see the Vanguard Fit design. So instead to use the pre-column, we use a cartridge that goes directly to the column. And the column has been manufactured with the holder, basically, already on the column. So you don't need to buy any holder. It goes straight to the column. And when you buy the column, you get the column plus the Vanguard pre-installed on it. And the solution is more compact and much easier to also to change. And as soon as you see a degradation in the column performance, it's time to change the Vanguard, and it will be easy. And each time you change the Vanguard, when you purchase a pack of 3 cartridge compared to a pack of 3 pre-column, you'll save a lot of money. So each time you use the Vanguard, you save money. That's also a very good reason to change to the Vanguard Fit design. So in summary, it has been, we have explored the theory or the impact of different acidic molecules like the carboxyl, phosphonate, phosphate, sulfate groups, and peptides that have more than 20% acidic residues, all the glycans, where you can imagine they have phosphate, many metabolites, and some lipids, like the one we have seen, are some examples. They all adsorb to the metallic surface, and they all get better results on the MaxPeak inert column. The thing is, at low concentration, the adsorption is more apparent, or it's more important. So that's probably one very important thing to realize first. And there's no negative consequence on the non-ionic molecules or positively charged molecule. So the reason I wanted to present this is because over the year, when we introduced the column, I remember I was looking at some specific examples. Not everyone was seeing a better performance. Again, maybe they were comparing a conditioned column to a new Premier column, and they were not seeing a huge difference. But then they came back to me later, giving me a different feedback, saying, oh, I just bought a new column, and then I see a huge difference between the MaxPeak and my new column. And I prefer the MaxPeak for that reason. So that came to me, and we have developed different application notes, like the one we have seen for the vitamin B. We have done some others for the thyroglobulin, cephalosporin. There was a lot of application notes where the MaxPeak is showing better performance. And that one paper that was about that table that we have seen, showing the correlation between the ionic character and the concentration effect, did explain a lot of things. And I thought it would be very, very important to share this information to everyone, because that's the same thing I repeat to many people now. And that's the feedback that I collect every day. I always say there's no bad results. There's always good data. show me everything that you have, share with me, and I collect that. And I thought it would be great to share that information with you. So those are the reference that I've used mainly for that seminar. The first one, correlation between the absorption of acidic analyte on stainless steel. I highly suggest you to read that paper. There's the information that I used to make that presentation. And this is a brand new, as you can see, end of April 2025. So as soon as I saw that, I was like, okay, I need to share this information to as many people as possible. So that's it for the presentation. It was not super long. I hope you learned something you appreciate. And I think it's time for the question and answer.
Yes, thank you so much, Guy. I really appreciate all your time. We do have a few questions, and feel free, everyone, to use that Q&A section to submit some more while we answer some. So I guess for the first one, we have, would you also have better performance using the max peak column for the detection / quantification / sensitivity of carboxy THC?
I don't have the data in front of me, but when we see the carboxyl attached to the THC or whatever molecule, it always a good indicator of increased sensitivity at lowest concentration on the brand new columns. So if you want to compare, that would be probably a very good thing to do. Compare a brand new conventional column to a max peak, inject both of them, and you will see the difference. As you can imagine, when we were looking at the ratio, it's not always visible. It's not like a small peak and a huge peak. But if you look at the area, if you compare the area of both of them, you will most likely see an improvement on the max peak premiere, and probably more reliable at all concentration out of the bat from the brand new column to a used column after several injections. That's probably the key element here.
Thank you. Next question. Do you have Premier columns for the analysis of glycan?
Yes, we have, we call the glycan columns, they have been QC'd with glycan. And so we have a variety of max peak Premier glycan column. I don't know them all, but there's for large glycans, small glycans, there's several columns we have available for glycan analysis. Most likely BH amide glycan column in the Premier hardware. Yeah.
Thank you. Do you have max peak technology for all column dimensions and all particle sizes?
No, but it's always changing. It's always evolving. So we always add new dimension. Recently, we introduced some on the PrEP column, on the 5 micron particles on different column dimensions. They are not there for everybody, for every molecules or every particle, sorry, but we are going there, most likely, yes. It's a question of time.
Thank you. Have you observed differences between carbolic acids, sulfates, and phosphates specifically?
Yes, that's what we have seen in the seminar. The table is showing carboxyl, dicarboxyl, so with molecules with different number of carbons. We have also see some phosphate and sulfate. They are all negatively charged. They all adsorb on the columns. You just need to look at, again, a brand new column compared to the max peak to see the difference in the peak area. But most likely you will see a difference for those molecules. And all of them, especially the sulfonic or phosphonic, will be more negatively charged. So the the adsorption will be greater than just the carboxylic acid.
Thank you. Let's go to the next one. Let's see. You injected ammonia solution to condition the column during your analysis. What solution can you use to condition a BEH column during analysis?
Okay, conditioning, it was not to condition the column, it was to clean the column after you, because this is not, this will be the opposite effect of conditioning a column. In the past, before the introduction of the MaxPeak column, people were injecting several times, several dozen, maybe 70 times, 80 times, the high concentration of the peptide or the molecule that was sticky to the column. I've seen people using bovine serum albumin just to make the column dirty. And they were adding the BSA in the mobile phase to keep the column dirty. And it was bad, but that was the best thing that people were able to do at that time. Things have changed now that we have those MaxPeak column surface are inert. We don't need to condition them. Now the ammonia or ammonium hydroxide solution was to clean all the surface, because you can imagine that after we take the ibuprofen at low concentration, some will coat the conventional column. And then when we go for the next experiment, we don't start with the same conditions. So we wanted to clean everything to remove all the adsorbed molecule on the surface of the metal. So the injections of a 0.3% ammonium hydroxide solution was just to remove everything, to bring the surface back to the initial state, like completely active as before.
Excellent. Thank you. Do we have limitations with the solvent and pH selection?
No, because the surface will not is covalently bound to the metal surface. All normal isopropanol, methanol, acetonitrile, all additive that we use typically, or all pH that we use for ammonium bicarbonate or carbonate or high pH, low pH, it all works. It doesn't affect the chemistry of the column. So there's no limitation on that.
Excellent. Could a Premier Helix column also help with tailing of basic compounds?
No, it's not designed. It will be good for the retention. The Helix is good for the retention of polar molecules, acidic and basic. But if you have some tailing on the, it's probably another topic we need to open on the Helix mode. There's probably some of the things you need to do, probably like increasing the buffer concentration, maybe 10 millimolar. If you don't have 10 millimolar or 20 millimolar of the buffer on column. So there's maybe some of the trick we can look into this, but the Premier is just designed to decrease the tailing of acidic molecule. It's really the acidic molecule that adsorb to the metal surface. The positively charged molecule does not absorb on the metal surface. Good question.
Let's see. Is PEEK tubing required to see these benefits, or can stainless steel tubing and high pressure methods still work with this new technology?
Well, that's a very good question too. We have the Acuity Premier column, Acuity Premier system as well. So all the metal surface have been modified, so they don't interact with the molecules from the injector, from the loop to the detector. So that's probably the best solution. PEEK tubing, again, if you are on the HPLC mode, it might work. It's not ideal. For the tubing, it's okay, but not for the column. You want a stainless steel or a premier column to be more robust, because some columns, I know some columns on the market, they have peak inside the tubing, but the surface are not good enough. They are not regular enough, and it's not performing extremely well. So it's not a good idea. But if it's a tubing, I think if you can use peak tubing, it's okay. If you are using at high pressure with the peak tubing, it's probably not working. It will pop up and it will not be standing the high pressure of the small particles create.
Thank you. Let's see. Just how acidic does a molecule need to be considered acidic for the premier column?
Can you repeat?
Just how acidic does a molecule need to be considered acidic for the premier column?
Well, if you have a carboxyl group on the molecule, it's acidic enough. Will you see a big difference? It depends on the concentration. So if you, for example, if you take one molecule with a carboxylic group on it, and you look at high concentration, you see already the effect will not be super evident to see. If you go to lower concentration, then you may see a better effect or a wider effect when you use a premier to a brand new stainless steel column. And again, as you inject samples to it, when you do your comparison, if you compare a column that has been used for several hundreds of injections and you compare to the premier on the carboxylic acid, you may not see a big difference. But again, you develop in the R&D, when you bring a new column to the production, you don't want them each time to have that initial problem with the conditioning the column when it's a severe effect.
Thank you. Which max peak premier column would you recommend for small carboxylic acids specifically?
I mean, it depends. It's a very good question. There's a lot of premier columns. We have the BEH, we have the CSH, we have the Cortex, we have the X-Bridge, we have the. There's a lot we can look. The thing is, if it's very polar, if it's difficult to retain, maybe there's a couple of columns we can suggest. It depends also on the selectivity, how many molecules you have, what matrix are you working on, what sample preparation have you used, because if you have, if you are, for example, using a SPE mixed mode, because many times when you have acidic or basic molecule, it's good to use the mixed mode sample preparation, because then you remove all the other molecules with similar polarity, because you keep only the ones that are negatively charged or positively charged. For example, on these ones will be the acidic, so you will only keep the acidic molecules from very polar to very non-polar. So the chromatography will be easier to do, as opposed to if you do a dilute and shoot, where you will get all the acids plus everything else that has similar polarities. So then you will need a gradient to separate them. It might be a little bit more challenging. If you have difficulties to retain them, I will probably suggest a HSST3 premier column or a CSH phenyl exyl premier column that will probably help you into the retention of acidic small molecules.
Excellent.
That would be the first one I try or recommend. But we need to look at more details on the method to give a real good answer.
Let's see. Let's take another one here. I'm looking to measure citrate and struggling with contamination issues. Is this also related to metal absorption issues?
Citric acid will absorb. We have seen. No, I didn't show it in the in this seminar, but yeah, we have isocitric acid, citric acid. They absorb a lot on the metal surface, so you will benefit using a premier column for sure. Yeah, it's a huge problem because it's a small molecule with relatively high negatively charged. So I would presume the negative charge on the molecule is relatively low. So it has more absorption.
Okay. Let's take another one. Is the Premier Max Peak version column of BEH C18 column working better for amino acid analysis as well compared to the original BEH RPC18 when we use Accutag reagent set?
Yeah, well, that's a very good question. We need to look into different things. If you have problems with detection limit, one thing that we do with the Accutag column, we do a quality control on the column, on the final column with the with amino acids. So if we have the same Accutag Premier, Accutag conventional, I will most likely vote for the Accutag Premier. But if we don't have the Accutag Premier, you take a BEH Premier compared to the Accutag. In terms of selectivity, making sure from lot to lot you have the same thing, I would probably stick with the Accutag column, unless you need extra sensitivity for some acidic molecule, acidic amino acids.
Let's see. Let's see. Have you done studies of max peak with plant extracts? And in this case, what do you expect to improve?
With what? Paint extract?
Plant extracts.
Oh, plant extract. I don't, I mean, again, we have seen the general rules. If you have acidic molecules from your plant extract, yes, you may benefit from that column. But I don't have a lot of, I mean, I've been working before with plant extract a long time ago, but I'm focusing into the clinical forensic for now. And when we introduced the max peak column, I was already into the clinical world. So I have more experience, more feedback into the clinical world than into the environmental pesticides analysis and plant extract. But I would imagine that if you have acidic molecules, that you have problems right now to get sensitivity at low concentration. Again, I would most likely explore the Premier, at least to compare, just to see if you see an improvement. Many things, it's like, I may not have a straight answer except for citric acid where I saw the example, or the vitamin B where I saw the examples. When I've not seen the data, I would say it's chemistry. We need to try to find out if it makes a difference or not. But again, brand new columns and the lowest concentration to see the effect, if the effect is great enough for you or not.
Awesome, thank you. I think we can wrap it up with Q&A there. Is there anything else you'd like to say before we finish up? And just to let everyone know, if we didn't get to your questions this time around, we will be able to get in contact with you. Feel free. Guy's email is there on the slide, and I will be available as well.
Yeah, thank you very much, everyone, for your participation. I did the seminar faster than I thought. That's good because it opened up a lot of questions at the end. I see your interest. It's great. And my pleasure is always to share as much information as possible to people. And based on the recent experiment that I saw with my customers, also with the newest application notes and the latest paper, I thought it would be a good timing just to say, well, these are a lot of answer to many of the questions that I receive in the field. So I just hope that you appreciate that. Thank you very much.
Yes. Thank you, everyone.